Hello, this is Mr. Henry, and welcome to Lessons 3.3. In this lesson, we are going to be looking at that third step of the process for solving equations, which is what happens when you have variables on both sides of the equal sign. So the essential question says, how do I solve equations with variables on both sides? Did you know that the actual skill in this lesson is how to move terms from one side of the equation to the other? And you'll actually be doing quite a bit of this for the rest of the year. But while you're here, the way that you move terms from one side of the equation to the other will always be using add and subtract. And also, we get our first problems of the year that don't have a solution, that do not have an answer. We haven't really seen any yet this year. This will be the first time we'll see them, and actually after this, we're going to see them quite a bit. We're going to see them now when we're talking about equations. We're going to see them in chapter 5, I think, when we're talking about systems of equations. We're going to see them when we talk about inequalities after the PSSAs. We're going to see them quite a few places. There's quite a few places we're going to see problems that don't have a solution. And what you're going to see is they all kind of resemble each other. But solving an equation. Here's what I'd like you to do. See if you can remember the 4 steps that we've already filled in. Steps 1, 2, 4, and 5. Can you remember those steps and put them in here without me telling you? I'm going to start writing without speaking aloud and start writing in the steps and see if you can stay ahead of me while you're going. And then we'll go through step 3 together. I'm going to cheat. Spell check. Alright, so I typed it because my typing is probably prettier and quicker than my writing. So here's the 4 steps that we talked about already. Step 1 was you get rid of the parentheses by dividing. Step 2 is you combine like terms. Step 4 was you get rid of the add and subtract by doing the opposite. Step 5 is get rid of the multiply and divide by doing the opposite. So the new step here is step 3. What happens if you get to a situation like this? And we have the same variable on both sides of the equal sign. Well, step 3 says we're going to get rid of the variable on the right. We're going to get rid of this term, this piece, the piece of the variable on the right. And we'll be getting rid of it by doing addition or subtraction. Okay. Now, I'm going to say that there is not this rule of getting rid of the variable on the right. This is more of a recommendation. There is no rule set in stone that says you have to get rid of the variable on the right, that says if you do the one on the left, it's going to be wrong. That's not true. You can get rid of the variable on the left. But what I found is most students prefer to have the variable piece on the left-hand side of the equation. Later on, when we're talking about solving inequalities, it's very helpful if you have your variable on the left-hand side of the equation. So if we just get in the habit of getting rid of the one on the right, it's going to make that process a little bit easier. There will be a few times where getting rid of the variable on the right, the way that we're going to do it, makes a problem a step or 2 longer, a little bit more work. But it's really nothing to be concerned about. Okay? So these are the 5 steps to solve pretty much every equation you're going to see. So here we go. Now, you can already tell that these problems look a little bit ugly. There's more stuff to them. So as I start solving here, I'm looking. There are no parentheses. I cannot combine anything. These guys do not have, these guys do not have the same variable. Those guys do not have the same variable. But I do have a k on both sides. And so I need to get rid of the variable on the right. I want to get rid of this piece by adding or subtracting. And if you look at it, this 11k is positive, so we're going to subtract him away on both sides. So now 14k minus 11k is 3k. I still have my 55. I still have my positive 94. Now from here, we're going to continue to solve. We're going to subtract 55 on both sides, because we get rid of the add and subtract before the multiply and divide. So we get 3k equals, that is going to be 39. Double check it on the calculator because I'm slightly unsure of myself. Okay, it was 39. And the final step to solving, since this is a multiply, we are going to divide by 3 on both sides, and k equals 13. I'm 100% positive that's 13. Okay, so once you get rid of the variable on the right-hand side, you see it's kind of like all the other problems we were doing in the last lesson, where you get rid of the add and subtract, then get rid of multiply and divide. Letter B. Will you fit out here? Yeah, you will. Okay, here's letter B. So I see the very first thing I'm going to do, parentheses, distribute. So 2 times m is 2m, 2 times 5 is 10. On the other side, I'm just going to copy him down. Get rid of parentheses. Done. Check for like terms. I cannot combine anything here. I cannot combine anything here. Done. Step 3. Do I have variables on both sides? Yes, I do. I have m's on both sides. So I'm going to get rid of the one on the right by adding or subtracting. Since he is positive, I'm going to subtract him away. So that gives me 17 here. On this side, 2m minus 4m is negative 2m. Plus 10 comes along for the ride. So once I got rid of my variable on the right, now look at this. That's just a two-step equation. So I'm going to get rid of the add and subtract, then the multiply and divide, and I'm done. So this should be just kind of boring stuff now. Minus 10, negative 2m equals 7. Divide by negative 2, divide by negative 2, and m equals, yeah, you get a decimal, negative 3.5. And that's okay. It's okay to get decimals. Decimals aren't wrong. Letter C. No parentheses. No combining like terms here or there, but I do have variables on both sides, so I'm going to get rid of the one on the right by adding or subtracting. Since he is positive, he gets subtracted away. Whoa, that was terrible. Better. Alright, so now 7n minus 10n is negative 3n minus 5 equals 13. Now I'm going to get rid of the add and subtract before the multiply or divide. So I'm going to get rid of this minus 5 first by doing plus 5 on both sides, giving me negative 3n equals 18. Don't forget this 3 stays negative. Don't forget that negative sign. Now when you divide both sides by negative 3, these guys cancel out, giving you 1n. On the other side, 18 divided by negative 3 is a negative 6. Holy cow. Now this looks pretty ugly. I mean, I've got fractions, I've got parentheses, I've got stuff everywhere. But actually, this is not that bad. What you're going to find out is when you start distributing, I think your fractions all cancel out. Check this out. If I take and I multiply here, and I multiply there, and feel free to use a calculator if you're not comfortable with that multiplication. Check this out. 3/5 times 5 is 3. 3/5 times 10 is 6. 3/5 times 10 is 6. On the other side, when you distribute, 5 times n is 5n. 5 times 2 is 10. Okay, so I have now distributed. I cannot combine anything here. I cannot combine anything here. I'm now going to get rid of the variable on the right. So to get rid of this 5n, since he's positive, I'm going to subtract it away on both sides. So this cancels out. I'm left with 6n minus 5n is positive 1n. Write down the rest of the problem. Now notice I didn't put the 1 there. You can. You don't need it. So from here, I'm going to get rid of this plus 3. To get rid of my add and subtract, I'm going to, well, it's an add, so I'm going to subtract it away. Subtract 3 on both sides, n equals 10 minus 3 is 7, and I'm done. Okay. I believe there are now a few problems for you to try. So here's letters E, F, G, H. Go ahead, pause the video, copy the problems down, do them on your own, as much as you can. Even if you get stuck on letter F, try letter G as well. Don't just wait and stop and then wait for me to catch up. Okay? Do as much as you can of these problems. Then when you're ready to continue, hit play and we'll go through them together. Okay, letter E. So there are no parentheses on either side to distribute. I do not see any like terms combined here. There's no like terms to combine there. So I do see, though, I have variables on both sides. I've got k's and k's. So I'm going to get rid of the variable on the right. Since this 7k is positive, I'm going to subtract it away on both sides. So he cancels out. I'm left with 5 minus 7 is negative 2k. And this stuff canceled out, so I still have a 13 over here. Now it's just a two-step equation, so I'm going to get rid of the add and subtract before the multiply and divide. So I'm going to add 8 to cancel out this minus 8. These cancel out, so I have negative 2k equals 13 plus 8 is 21. Divide both sides by negative 2 to cancel out my times by negative 2. These cancel and give me 1k equals, and that math is negative 10.5. Okie dokie. Letter F. So here, I'm going to, again, not distribute, because I can't distribute. There's no parentheses. I am not going to combine like terms, because there's nothing to combine here. There's nothing I can combine here. I am going to get rid of the variable on the right. So I'm going to subtract 8b on both sides to cancel out this positive 8b. So 2b minus 8b is negative 6b. Write down the rest of the problem. Don't forget this 9 is negative. That is actually a mistake I see quite often, is this negative right here gets dropped from this step to the next one. If you dropped him, put him in there and see if you can fix your mistakes from the rest of the problem down. He should still be a negative 9. So now when you solve, you're going to subtract 9 on both sides to cancel out this plus 9 here. Negative 6b is equal to now a negative 18, where before you might have had a 0 if you thought that was a positive 9. Divide both sides by negative 6 to cancel out the times by negative 6, and you get b is equal to negative 18 divided by negative 6 is a positive 3. If you got 0, you probably forgot your sign right there. You made that a positive, and that's why you would get 0. Letter G. I can distribute here. If I distribute the 3 times the h and the 3 times the 5, I start by getting a 3h plus 15. I cannot combine anything on either side, so I'm going to now get rid of my variable on the right. So I subtract 3h on both sides. These guys cancel. On the left side, 1h minus 3h's. 1 minus 3 is negative 2h. This 15 is positive, so he comes down positive. So now it's a two-step. So I'm going to get rid of my add and subtract before the multiply and divide. So if I subtract 5 on both sides, these guys cancel out. I get negative 2h is equal to 15 minus 5 is 10. Divide both sides by negative 2 and, whoa, what is that? It's supposed to be an h. H is equal to 10 divided by negative 2 is a negative 5. Now, I haven't checked one of these problems yet, like by plugging my solution back into the answer. So let's check this one very quickly while we're here. Erase this junk. So here's how you would check, especially if you have variables on both sides. So to check your solution, you take the answer you get and you plug it in for the variable everywhere in the problem. So I'm going to plug in a negative 5 for h here and here. If I write down the rest of the problem and do the math, the two sides should be equal to each other. So over here, negative 5 plus 5 is 0. Over here, inside my parentheses, I have negative 5 plus 5, which is 0, times by 3, and 0 times 3 is still 0. So yeah, this math checks out. Letter H, the last of this type of problem. So I do have parentheses. When I distribute here, my fractions are going to go away because half times by 8. Half of 8 is 4. Half of 16 is 8. I cannot combine like terms on either side, so I'm going to get rid of the variable on the right. So I'm going to subtract 7c on both sides. So he cancels out here. And so my 4c's minus 7c's is now negative 3c. And let's see, now what do we do? Well, we have to get rid of the add and subtract before the multiply and divide. So I'm going to add 8 to cancel out this minus 8. Giving me 3c, oopsie, negative 3c is equal to 16 plus 8 is 24. And then our last step to get rid of this times by negative 3, if we divide by negative 3, we get c is equal to negative 8. So now we've solved some fairly complicated problems. Now we're going to start to see what happens with some of these special solutions. So let's see here. I'm going to tell you that these problems are going to have special solutions, and we're not going to be able to tell, you may not be able to see just yet why. So as we start solving, we're just going to solve like normal, but something weird is going to happen as we start to solve. So I'm going to start by distributing. That's my normal first step. So 5 times 2 is 10x. 5 times 1 is 5. Okay. Copy down the rest of the problem. I cannot combine like terms here. I cannot combine like terms here. So I get rid of the variable on the right. And since he is a positive 10x, when I subtract 10x on both sides, wait a second. These both cancel. 10 minus 10 is 0 here. 10 minus 10 is 0 here. These both cancel. I don't have any more variable left, right? So what's left over is 5 equals 2. There. Oh, my goodness. That equals, that eraser is huge. 5 from here, 2 from there. So I got 5 equals 2. Now, you're probably asking yourself, or you know the answer. 5 does not equal 2, Mr. Henry. I know that. 5 does not equal 2. But actually, this is a good piece of information, because this tells us, because 5 does not equal 2, because this is false, that actually means this problem up here will always be false. It will never be true, because this problem has no solution. There is no solution to this problem. No matter what you plug in for x, the two sides will never be equal. This side over here will always be bigger than this side over here. And I can't really prove it very well, but I can at least show an example or two to help maybe solidify the idea. If I pick some number, 3, if I do the math on both sides, the two sides will not be equal. This side gives me 30 plus 2 is 32. This other side, 5 times 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. 7 times 5 is 35. So does 35 equal 32? No. And I can keep trying problems all day long, and I'm never going to find one that works in this problem. When your variables cancel out on both sides, come on. When your variables cancel out on both sides, you are going to get a special solution. One of those special solutions is no solution. That happens if, when your variables cancel out, if the remaining numbers are not true. If the remaining equation is not true, in this case 5 equals 2 is not true, that means there is no solution. Okay? Now, the other type of special solution we're going to see here in letter B. So as we solve this one, we're going to just do like normal. So we're going to distribute. This gives me 4 times negative 2 is negative 8. 4 times 3x is 12x. I cannot combine anything on either side of my problem, so I'm going to get rid of the variable on the right. So I'm going to subtract 12x, and look at that. They both canceled out again. That is the sign that this is going to be one of those special solutions. If your variable cancels out on both sides, you are going to get a special solution. So these canceled out. What's left is negative 8 equals negative 8. Now, is that true? Does negative 8 equal negative 8? Yes. Yes, it's the same number. They are equal to each other. So since these are equal to each other, this is the other special answer we get. This one is called all real numbers. Or if I write out numbers for you. It's all real numbers, meaning that every single number you can possibly imagine is a solution to this problem. Every one of them. And here's how I know that. Because when my variables canceled out on both sides, I got something that is true. And that means this problem will always be true. No matter what number you plug in, it will work. So, an example. If I pick some random number, let's try 2. If I plug in 2 for x, this side I get 12 times 2 minus 8. The other side I have some ugly parenthesis math to worry about. So on this side, 12 times 2 is 24. 24 minus 8 is 16. On the other side, 4 times this junk. Now this junk all in here, if I do my order of operations, 3 times 2 is 6. 6 plus negative 2 is 4. And then 4 times by 4 is 16. My math worked out so that it's true. And it's not just a coincidence that I happen to pick the one right answer. No matter what number I plug in, they will always work. Okay? So, if your variables cancel out, special solution. If the remaining equation is not true, that means there's no answer. There will never be an answer. If the remaining equation is true, then every number will be an answer. Okay? Letter C. Distribute. 28c equals 8. On the other side, 28c minus 5. I subtract 28c to get rid of the variable on the right. When I subtract 28c from the other side, this also cancels. Special solution. I'm left with 8 on this side, a negative 5 on that side, and this problem has no solution because this is not true. Make sure you don't just stop here. The answer is no solution. The answer is not 8 equals negative 5. This is the evidence to tell you the answer is no solution. Okay? Letter D. Distribute, distribute. 12g minus 6. 2 times 6 is 12. 2 times negative 3 is negative 6. On the other side, 12g plus 6. When you get rid of the variable on the right, subtract 12g on both sides, and they both cancel again, which means special solution. If your variables cancel on both sides, you're going to get one of these special solutions. Now here, I have 6 equals negative 6. A lot of people forget about this negative, and they just bring down 6, and they go, it's all real numbers. No, it's not. This is a positive 6 on one side equaling a negative 6 on the other. This is no solution. These are not equal to each other. Positive 6 is not the same thing as negative 6, so there is no solution. Here are 4 for you to try. If you could, please pause the video, do them on your own right now. When you are ready to continue, hit play, and we'll go through them together. Okay, so let's go. Let's go. We're going to distribute here and here. 3x plus 9 on the other side. 3x plus 9. I'll be honest with you, you could actually stop the problem right now. Because look at this. These two sides are 100% identical. 3x plus 9 equals 3x plus 9. That means no matter what number you plug in here for x, the two sides will always still be equal. If you plug in 5 on one side and 5 on the other side, you're going to get the same answer. The math is the same on both sides. This problem has all real numbers as a solution. Now, if you didn't see that and you kept going, you would continue on by subtracting 3x on both sides. They cancel out. These both cancel. You get 9 equals 9. Still all real numbers. If you see that both sides are identical, then you can stop the problem and just determine that it's all real numbers. Letter F. Simplify, simplify. 5x plus 3x is 8x. 5 plus 3 is 8. 2 times 4x, this is a multiplication. 2 times 4x is 8x. All real numbers. That is identical. Now, if you didn't see that for some reason, and you subtracted 8x on both sides, maybe you like doing that step. This cancels. This cancels. What's left? Well, 0. 8x minus 8x is 0. 8x minus 8x is 0. And this is still true. Both sides are equal to each other. All real numbers. Letter G. I'm going to move H out of the way for a second here. Letter G. Distribute. Boom. Boom. 4x plus 6. There we go, Mr. Henry. And on the other side, I can combine my 3x from here and my 1x. There's 1x here. 3x and 1x add together to give me 4x. Now I will get rid of my variable on the right. So I'm going to subtract 4x on both sides. These guys cancel out. And these guys cancel out, and we're left with 5 equals 6. That is no solution. It is no solution because that is not true. 5 does not equal 6, and there's no number you could plug in for x here that would make one side equal the other. This problem has no answer. Letter H. distribute, distribute. 4x plus 20 minus 1. On the other side, 19 plus 4x. Okay. I can actually simplify a little bit here. 20 minus 1 is 19. Now, if you're astute and you look at that, you can actually see that these two sides are the same. It's a positive 4x and a positive 19 being added together on both sides. And so you could actually stop right now and say that this problem has all real numbers as the solution. Now, if you don't see that, if you didn't see that, and you kept going, you subtract 4x on both sides. These cancel, those cancel. 19 equals 19. Still all real numbers. Okay? Example 3 here says, find the perimeter of the square with a given side lengths. Okay, so they gave us a square, and they gave us how big the sides are, 2x plus 3 and 5x minus 9, and they want us to find the perimeter. If you don't remember how to find perimeter, the perimeter of any shape is you add all the sides together. Now, since this is a square, there are 4 sides. We're going to add all 4 sides up, and that would be the perimeter. Now, in order for us to do that, we actually have to know how big are the sides. If I know how big this is, if I knew this was an 8, and they're all 8, then I would just take 8 plus 8 plus 8 plus 8 and get whatever that would be. Okay? But I don't know how big the sides are. The problem doesn't tell me. So that's the puzzle. The puzzle is figuring out what is this as a number and this as a number. So in order to figure this out, there's actually a little bit of background knowledge that you should have that says a square, in a square, all the sides are the same length. So this side here is the same as this side here. Mathematically speaking, that first side is the same, equal to, the other side. And since it's the same, since they are equal to each other, we can set them equal to each other, and we can now solve this little equation to find the x. And so we're going to do that. I'm going to, let's see, there's no distributing needed. There's no combining like terms on either side. I have variables, the same variable on both sides, so I'm going to get rid of the one on the right. I'm going to subtract 5x from here and here. That gives me 2x minus 5x is negative 3x. I'm going to then, let's see, well, get rid of the add and subtract before the multiply and divide. So I'm going to get rid of this plus 3 by subtracting 3 on both sides. Negative 3x is equal now to negative 12. Divide by negative 3, and x is equal to 4. Now, it would be wrong for me to say, oh yes, my perimeter is 4. No, it's not. That's very wrong. It would be wrong for me to say, oh, okay, so each side is 4, so I take 4 plus 4 plus 4 plus 4. No, it's not. All we did when we found x equals 4 is we literally found this guy right there. That x. X is 4. Not the side length, not the perimeter, x. In order to find the side length and find the perimeter, if we plug in 4 for x, 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. Over here, if you plugged in 4 for x, 5 times 4 minus 9. 5 times 4 is 20. 20 minus 9 is 11. Look at that! Both sides I got 11, which makes sense because it's a square. All the sides should be the same length. So all of them are 11. So now I go, you know what, okay, so 11 plus 11 plus 11 plus 11, my perimeter is 44. Yes, it is. That is the final answer to the problem. The perimeter of the square is 44. And it doesn't really give us a unit, or we'd put units in there too. Letter B, last of these problems. What is the area of a triangle if the area is represented by that, 3x plus 2, the base is represented by 4x minus 8, and the height of the triangle is 6? The formula for the area of a triangle is this. So here's my hint to you. You're going to take this formula. You're going to plug in what they tell you to plug in, where they tell you to plug it in, and simplify and solve. And you should be able to get to a situation where it looks familiar, and you should be able to solve, okay? So pause the video, try this on your own right now. When you are ready to continue, hit play, and we'll go through it together. Okay, so from here, all we need to do then is to plug in our numbers. So it tells us the area is this 3x plus 2. 1/2 is 1/2. It tells us the base is 4x minus 8. It tells us the height is 6. So now we have an ugly formula, but an ugly solvable formula. So if I do one step at a time, this side needs quite a bit of simplifying. The other side I can't really do anything with yet. So I'm going to start by simplifying. I'm going to distribute. So 1/2 times by 4x is 2x. 1/2 times by negative 8 is negative 4. And the rest of the problem just comes along for the ride. Now, I'm going to distribute this way. This is still this stuff in the first set of parentheses times by the stuff in the second parentheses. So I'm going to take 6 times by this stuff. And what we're going to get is 6 times by 2x is 12x. 6 times by negative 4 is negative 24. Still have 3x plus 2 here. Now, it's just like the problems we were doing earlier. I've got variables on both sides, so I'm going to get rid of the variable on the right. I'm going to subtract 12x on both sides. And that gives me, let's see, 3x minus 12x is negative 9x plus 2 equals negative 24. The rest of the stuff just comes down for the ride. And now we, to get rid of this plus 2, we're going to subtract 2 on both sides. So this cancels out. So we have negative 9x equals negative 26. And finally divide both sides by negative 9, and x equals whatever that gives us. Negative 26 divided by negative 9. 9, there we go, equals 2.8 repeated. Positive 2.8 repeated. Okay, so that is the area of the triangle. Yeah, it's ugly. It was an ugly problem, but it wasn't undoable. Distributing, getting rid of the variable on the right, get rid of add and subtract, get rid of multiply, divide. It's the same steps we have been doing in all the problems. It's just a little bit uglier. Summary for lesson 3.3 says, how can you tell if an equation will have one solution, no solution, or all real numbers as a solution? Okay, so you can answer that summary question on your own. This has been lesson 3.3. Thank you for watching.